I heard something, but I don't know what it was. Okay. Okay. And there's something wrong with this slide. This and session ID greater than 50. I meant to correct this because that's tried to avoid any background processes, but as we all know, background processes may go over a SPID number of 50. So I meant to correct that. So please strike that line. And then also, I'm not looking for me. I don't want to see what I'm doing. I don't want to see this query because I'm not going to tune this query. I'm trying to collect the information. Any questions about that, just storing that off and then going back and looking at it? Okay. Now, how you can go off and get now other information about it is at different intervals, you can go back and use DM exec query stats, which is another DMV that will actually give you execution counts, logical, physical reads, and writes, and total rows. There's a lot of information in this exec query stats view. You just have to grab where the SQL handle that you collected in that other query is and do this at some interval. What we do with our product is we actually go back, because the statistics are usually cached, so we'll go back every 10 minutes and grab that and do deltas. But you can actually, look at that. Because again, these DMVs are accumulative over time. So you have to kind of, if you want to know how many executions, you're going to have to take one poll and then subtract it from the next to see how many it did within that time frame. Other information then you can gather is using these table functions. DM exec SQL text, we grab the SQL handle, but if I want to see the full text, I just basically pass the SQL handle to this function. And you can see my example here. I'm selecting star from, and then I do sys.dm underscore exec underscore SQL text, and I pass it to SQL handle. Now the trick here is don't put quotes around the SQL handle. You'll get a funny error message. It's a raw value, so you'll just pass it that way. Again, if you want the query plan, you can do DM exec query plan, and that's again you just pass the plan handle that we've gathered from our first query, and you pass it into that table function. And finally, you may want the database name, and again. These you can do later at some other time. They're in cache. You can usually do this less time and get this information out. But regardless, when you do that, you're going to get weight types along with that. And what weight types are the resources that are either being used up and weighted on. Now, I used to have a count of 2008. In fact, I know when we were working with 2008, 2012 came out, I think there was actually about 165 new weight types. And you can see there's 649 weight types in 2012, 771 weight types in 2014. They keep getting bigger, more of them, more specific, so you can see exactly what resources being weighted on or used up. I like to categorize them because 771 of them are a lot of weight types to get your hands around. And there's no good way to categorize them within the DMVs. They don't give you that. They just say, here's all the weight types. But if you use Performance Data Warehouse or Management Data Warehouse, whatever you call it, basically, if you actually set that up, has anybody used Management Data Warehouse? Okay. There's a core table that sits out there as the weight categories. And it actually categorizes some of these weights. Not all of them, but it does categorize, the good majority of them into CPU, network I/O, buffer I/O, that type of thing. So they're easier to look at. We're going to get into weight type examples, but if you do want to categorize and see where is the majority of work, you may decide to just actually create a management data warehouse. You don't have to really use it, but you'll get that core table and get that mapping. Here's some sample weight types. Common ones, pretty much. Write log is basically telling us that it's waiting for a log flush to complete. And if you know that you're waiting all your time on a write log, there's different clues that you can use or different solutions that you can take to actually reduce the time spent on that. And so that's the key in tuning these things. So if you actually look at weight types, you're always going to have a solution to try to reduce the time spent on. Blocking, and there's a bunch of blocking. The LCK weights, they're all waiting to fire lock. The suffix of each one, S is for shared, or select, U is for update, and then the X is for exclusive. So you can actually kind of see what type of log you're waiting on.
So the write logs, that's when you're waiting on your inserts to get into your database. Would you ever see write log wait if you're creating tables in your queries, things like that, or your stored procedure? Or that's all buffer?
Write log is really the fact of commit.
Okay.
It's really not the fact of insert. It's the commit afterwards. And so what happens is every time you do a commit, they have to flush, the log has to flush to complete it and say, okay, I've got it, I'm solid now. So for temp, you're probably not committing in temp, so probably not. Async network I/O, this is a good one, and I've got some case studies of some of these that we're talking about. But async network I/O is one that is kind of an ugly one, if you will, because a lot of the third-party products like Access, Microsoft Office, there's other tools that they'll grab all the data from the database, bring it back to the client, further filter on the client. And what that does is it pretty much, ties the database hands of any tune because you're doing it like star, no where clause, right? I'm just taking the whole table and I'm going to further filter on the client. Well, what happens is, there's a lot of chattering going on between the server and the client, and they're active sessions, so it is taking up processing, and it's a very inefficient way to do that. So async network I/O is not one of my favorite wait types when I see it out there as being my top. The only other exception to that is if you have very poorly written SQL and people are waiting for it to come back to their browsers and they give up. And so they shut down the browser. Well, when they do that, they often don't exit out of the application, right? So what's happening is they shut down the browser. They didn't tell SQL Server they went away. So SQL Server maintains an active process and chatters to an empty port. And that can go on for days. Those are the fun ones to find because you go, oh, you need to educate your users or fix your application so that it knows to actually shut down when they shut down the browser. So that's kind of a fun one of that one. OLADB is another wait type. So if you have an OLADB provider, such as maybe you're sending mail out of Microsoft or out of SQL Server, or you've got link server, you might wait on an OLADB wait. And then wait for is an idle event. Now, developers in here, have you ever used wait for? You can wait for a few seconds or a few minutes or whatever. That's one that you can program. It's an idle event. You probably don't want to look for it because it just tells everybody to wait. And then a page I/O latch, and then there's a number of these. There's exclusive, there's shared, and all that. But it's waiting for disk to memory transfers. So those are just some of the examples, but you remember there's 771 of these. A lot of times, though, you'll see the common ones trickle up to being the top in any instance that you're running. Okay, I'm going to switch on a little bit, about response time analysis, and back to that. There's two tools that are compliant if you're going to use this methodologies. One is the tracing tool. If you use tracing, that's going to focus on, everything a session does. Basically, it's going to trace every step, and oftentimes gives you, the actual values to the parameters that you're passing. You can use SQL Server Profile. In 2008, just so you know, extended events came out. In 2012, SQL Trace is no more. You can say SQL Trace calls all you want, but the underlying mechanism is extended events. And they have deprecated SQL Trace, although it's still there in 2014, those calls, the views, and all that. But the underlying mechanism that's running that is in extended events. How many of you have used or looked at extended events at all? How many, anybody using Trace? Just out of curiosity, okay. So you might want to look, there's a DMV out there that'll tell you whether you're using Trace. It's got a counter that if it's equal to 1, it'll say, you're using Trace. And so you may want to make efforts to get away from those calls and start going to extended events. Like I said, SQL Trace is still there in 2014, but they did say it was deprecated in 2012. Okay, so tracing is a good thing, very precise. The problem is you can't, it's a lot of overhead sometimes to keep tracing on. So what you might want, you have to know when the problem is going to occur in order to turn tracing on, so sometimes you miss it. Also, it's difficult to see trends over time. And I'm a big fan of trending, because you got to know what normal is before you can figure out what abnormal is, in my opinion. If you're responsible for a bunch of database instances and you have to go look for the needle in the haystack, well, now you have to know what's normal in order to figure out what's not normal. Otherwise, you're going to find a lot of needles, and they may not be, the ones that you want to find. So continuous database-wide monitoring tools do have a place in everybody's organization. I talked about that one query that you might want to pull and take that off and continue to pull over time. Because what you need to see is 7 by 24, perspective of things, so you can see historical versus and real time. It allows you to go back in time. I don't know how many of you go on vacation, you come back and they said, oh, last Wednesday, everything just went to a standstill. And my standard answer was, well, try to recreate it again and see what went wrong. I don't have anything. But with these tools, you can go back last week and you can see what went wrong without you being there. Tracing, the monitoring tools don't often give the detail of tracing, but also they can give you a lot of good reporting, so you can report to other groups. Okay, there's four key principles to response time analysis and this wait time methodology. And so if you think about it, I've been saying it all this time, and they are, basically the SQL view. You're going to gather all statistics and information at each SQL statement level. There's a time view where you're going to measure time that it takes, not the number of times something occurs. And then there's a full view where you're going to measure every wait individually for every step to isolate your biggest problem. And then finally the historical view, where you can store off that information long term to spot trends and anomalies and relationships. So it's a lot easier to get in there and find root cause to a problem with these type of views. Okay, again, response time analysis, and I know I harp on this, but how to use it? Well, as a DBA, you're going to want a proactive view, right? You're going to want to have it when or if a user complains, and you're going to use it when you're firefighters. If everybody's screaming at you and you've got to find root cause, you need a tool to get you there quick. Blocking issues, sometimes they are a tuning issue. Blocking can be, a concurrency issue, and maybe more of a problem of concurrency with everything running. So just note that. And then long-term trends is nice to see over time as your data grows and your workload changes. And then finally, the current view. You got to see something right now. And I've got slides of these just to kind of show you. If you wanted to use this methodology, and these are our tools, but if you just ran that one query, you could get the same information from that one query. And here is a proactive view. And this proactive view is actually telling me that, I've got 30 days, I've got from January 17th to February 4th. And what we're looking at here is the top 15 SQL statements running in my database. And each color is a unique SQL handle, if you will. And if you notice here, notice the time spent. Beginning in January, I was spending about 100 minutes in the top 15 in the database a day. Look, it jumped up on January 28th, and actually it about tripled in size on January 29th there. I don't know. Can you read it? I can zoom in. Okay. And you notice some of the bars are getting bigger and taking longer and longer and longer. If you see this, you can do something about it, maybe before end users come complaining. Because definitely, if things are now taking 3 times as long, they're going to be coming and knocking at your door. Here's when a user complains. Basically you can drill down to a second if you poll every second with your data and your query that you're running and see what was running during that time frame. And so we can actually see when a user complains, we can actually pick on that user because we've grabbed that DB user ID from the DMVs, and we're watching him. So now I have a view of my top database users, and I can see that top one, spent 2,000 minutes, so over half an hour in the database. And we further drilled down to see what that guy was running, and you can see that he was running this bottom query, which we actually named Business Hierarchy. And I can kind of zoom in on that so you can kind of see that. But I'm slowing down here for the folks on the web, because sometimes when I zoom in, I think it's kind of slow. But as you can see here, this one user basically had spent, quite a bit of time, 550 minutes in the database on that one SQL statement. So which one, since he's complaining to me, am I going to focus on? No brainer, right? I don't have to go in and kind of, okay, what were you doing, and figure that out, because it's right there with that response time. And not only that, notice what it's waiting on, CPU, as you can see, followed by page latch exclusive, and then a page latch shared, but hardly, very little I/O. It's mostly CPU. We can further, because you reported that off, we can further see what it did, during that time frame. So we looked down at the same time frame, and here we can see, it actually executed 17,901 times, 97 million, almost 98 million logical reads. That's why it spent so much time on CPU. It spent, when you're using CPU, what often happens is it's spending that time traversing memory, trying to get the data out of memory. If you have an inefficient query, okay, you're going to see high CPU utilization. And the reason why? So look at your logical reads. It's probably reading far too much data in memory to actually, produce that result set. This is the first thing I usually look at is my logical read. Because if you think about it, every query has to do a logical read. It may not do a physical, because it might already be in memory, right? But it has to have it in memory and read it in memory to do anything. So it's got to do at least one logical read. So if you can reduce that, you've actually sped up your system. Finally, blocking issues. Again, when you record off that one query that we showed, you're actually recording off the blocking session ID. And then you can go look at that session's ID and see what he was running during the same time frame. And so that's what this one is actually doing. It's showing you, here we had a SPID of 78. It caused, 221 seconds of wait. We have all that good information because we did that in our query. We got the user, the program, the machine, and we can see the details below of what he was running while he was blocking. And sure enough, he was running this one SQL statement, which we put name on it. I should have printed it out. But what was this guy doing while he was blocking? Well, look at his wait types. CX packet, anybody know what that means?
Waiting for parallel processing.
Parallel processing. So he was doing some parallel processing, actually taking more processes to complete his than, the ones up here. So he's robbing Peter to pay Paul, I often say, because if you've got a one query that needs multiple processes, then maybe you should look at that and tune it. That's not the easy answer is to turn on parallelism. It's actually, not as good. And sometimes you use parallelism and they even get worse because they get too chatty. The workers actually spend too much time talking to the coordinator and, spend a lot of time.
We actually ran across this in a SolarWinds database. And believe it or not, one thing that we did, I was hesitant to mess with the parallelism parameter at the time.
Yeah.
So system guys went back and they saw that they had really ratcheted down the amount of memory that SQL Server database can use. So they kind of added it up some. Because I was saying there was some problem with memory. It was trying to run all these parallel sessions and it wasn't getting enough information wasn't ready in memory for it to do it.
Just thrashing it, probably.
Right. So, and it seemed to help, and it definitely made some adjustments.
Yeah.
So, I don't know, but yeah, we ran across that same.
Yep, This one is a fun one to run into, because a lot of times the way to tune this one is turn off parallelism. Other ways, though, is to look and see, what the underlying workers are waiting on. CXPAC is kind of the generic coordinator that's, saying all time spent. But if you can catch it while it's running and you go out and look at the wait types of its children, all the other processes running underneath it, you might see that you have a disk problem or other problems like that.
I just assumed it was some ad hoc query that somebody kept running into the system, because it wasn't constant. It would pop up, last for a while, and then it would go away.
Yep.
It happened all throughout the day.
And it could be, because I know the SolarWinds, you have the network product.
Yeah.
Yeah, and it could be because that's such a kind of a dynamically built thing depending on the business. It could be one query that was built and running that way, not all the time, but sometimes the way they do that is. A funny story, and I'll digress a little bit, is we were purchased by SolarWinds, last October. And of course, they're trying to get to learn our products. We're trying to get to learn their products. And we had a huge customer they were trying to sell to in the government industry, and it was their network product, and they couldn't make it work for 4. And so one of the sales guys came to me and he said, look, if we could get them to install Arsenal, Ignite at the time, just for a few minutes, if we could get them to do that, could you sign on and maybe diagnose the issue? And so, in being government, it's very hard to do this all across the web because you can't see anything. They won't share anything with you, no GoToMeeting or anything like that. So, I talked them through on the phone, not seeing what they're doing. They downloaded, installed, got it running. And we begged them, just give us 10 minutes to look at what Ignite was telling them. And within 10 minutes, I found their problem. We sent it to the development team for the network. Overnight, they worked on it, got the piece back to them to get.
That's what helped me. We actually trialed the SQL Analyzer tool, which actually helped me go down and find the issue that was popping up.
Yep. So the long story short is now what SolarWinds has done is they said, okay, we're putting DPA, which they've renamed Ignite, into our development lifecycle. And so before anything is, goes in any further after development, it has to first run and be monitored by DPA so they can find any problems. So it's just kind of a funny story. But yeah, CXPAC is one that you're going to see, especially if SQL Server sees that it's a high-cost query. What it's going to try to do is say, well, I know this is going to be costly, so I'm going to put multiple processes at. And so you can control that. There's different ways of controlling that. But again, that's kind of a fun weight type to look at as well. Finally, long-term trends and long-term issues. This is just a kind of an interesting case study. This is a picture from July. Let me see. It looks like from July 31st to September 9th. So it's about 3 months, 2 months. And you can see they actually tuned. See what they were running at first? They were running about 140 hours a day. We're looking at, I think it's the top 15 SQL statements here. So we've got 140. It looks like they got a little trend going on here. I don't know what day this was, but basically they actually got it up to 220 on this day. But then they started tuning, and they actually tuned this thing down to spending very little time in the database. And that's what long-term trends and that type of information, when you look at response time, will give you. Now, this is something that as a DBA or developer, if you tune something, you could brag about. Because look at how much time you gave back for other processing to happen. Okay, so finally, the current view is always important, and you've got that when you're pulling that information every minute and looking at response time. Okay, enough about that. Let's get into some of the case studies so we can start talking about some of this. So these are real stories. Some of them are pretty old. So I've got a 2000 case in here as well. But these are real stories that came to us as a company, as I worked with different customers and prospects. And we had a situation where we had a customer who, the developer was having problems. He was actually trying to get his code to production. And they actually, what they had done is they had a license to monitor the production, not development. And they came to us because they were fighting, the developers were fighting us with the DBAs, because DBAs wouldn't let them promote their code into production. And the reason why is because the developer was complaining about performance in his development database. He was trying to load some test data, and nothing was happening. And of course, the DBAs just suspected the whole development effort. And so what they wanted is they wanted a key and a free trial to actually look at the development database. And so they downloaded our tool and pointed it at their development database for a couple of weeks. And basically they used this wait time methodology and RTA to determine what the process was waiting on that this developer was complaining about. And so, as we look here, we basically see, a no-brainer. Looking from at this time, when you look into this, you can see that there's SQL statements we're waiting on, but none of them spend hardly any time in the database, except for this top one, which we named instance loop, and identified it right away. It didn't take very long to identify this at all, and it was spending all of its time on a write log. In fact, it was spending, only write log and CPU is where it was spending its time. So the response time analysis tells us that which SQL we should focus on should be the insert loop one, right? I mean, it was spending the longest. There's no brainer that was the one we wanted. It was taking 10 minutes each execution, and or I don't know, it was taking 10 minutes. I think we'll see that it had a loop in it, and it was spending 96% of the time on write log. Okay. So if we go look at the code, we can see what this developer had done. He's actually, trying to create some test data. So what he was doing was he was inserting 70,000 rows and into this table in a loop, and each time he did that, it took about 10 minutes. And you can see that he just began a tran, insert, and then he's making up some data into this JPET store DBO product. Well, let's go and see what write log tells us. And so write log, what the description of it means, it occurs while you're waiting for a log flush to complete. Common operations that cause log flushes are checkpoints and transaction commits, right? So what are you going to do? Some solutions, you can actually commit data less often, batch it up, in other words. Or maybe you need to add additional I/O bandwidth to the disk subsystem where the transaction log is stored. Maybe there's something slow there. Or maybe, check to make sure you've got non-transaction log I/O from that disk. Move all your, make sure you don't put your data files with your log files, that type of thing. Or move your transactions log to a less busy disk. Or resize the transaction log can also help in some cases. If it's a great big log, you might be able to resize it and get some better performance. Well, let's go back to what we found. And what we found is if you looked at the original query, where is he doing the commit?
Inside the loop, every record.
Yeah. So just by moving that commit out, out of the loop, we actually reduced it down to 28 seconds. Probably still, could do a little more tuning, but still, quite an improvement from 10 minutes. Another problem, okay, so a locking problem, and this was actually a web application, and I believe, if it's right, I think it was, actually revenue generating, and so the DBA team was really concerned that they were going to, escalations were going to start and they were going to get blamed. So what they actually did was, asked us. They were monitoring what they told, but they asked us to help them read this data, and we got on and actually looked. And this one, basically, you can see here that. Let me just kind of go over here. We've got about 8 days to 7 or 8 days here of data, and you can kind of see on March 1st or March 5th here, we're taking about an hour and a half, and then you can see that blue bar there. It just keeps getting worse. And by March 9th, it was spending 8 hours in the database. And the end users were complaining. It had to do with get state. And actually, it was a way of getting state for the session that was running. And every session had to run. And so it was really slow complaining that they couldn't get their work done. So we look at this, and we can see that what it's waiting on. And if you look here, it spent 49% on a lock, and the U is an update lock. Okay, and then it also spent 27% of the time on write lock. And it looks like followed by CPU, and then there was another lock going on too, an intent for exclusive lock, I think is that other one. And then there's some network I/O. And this is how I can tell this was a 2000 database because network I/O after 2005 changed to async network I/O. So, but basically, 60 or 76% of that was spent on those two waits. So where should we focus? On those waits, right? So let's go look at the procedure, and basically this is a stored procedure, and it was running that update there that you can see. So what does that information tell us? That, our biggest problem in the database was get state. The wait types are lock, an update lock, and then write logs. And the time that was being spent was 8 hours of wait. So let's go to the manuals, and what update lock MU means is update lock normally occurs when attempting to update a row that is locked by another session, right? Who should resolve it? This is something we give in our tool, but basically solutions are for shared lock. You want to check the isolation level for the transaction. Keep transactions short as possible. A lot of times locking is because you've got inefficient queries taking too long to complete, so other queries can't run. In SQL Server, readers block writers. So you got to be careful because if you're taking too long to read, you're blocking somebody from updating that data. So, the other thing is you might want to check memory pressure. If you're doing more physical I/O and you don't have enough memory, and it's not in memory, it slows things down. So you want to keep it as much in memory as you can. Write log, again, I just listed it here again so to review. Usually doing log flushes due to commits. We look at additional I/O bandwidth. Maybe move the transaction log or resize it or commit less often. Well, we found that the locking and logging wait problems to be 76% of the total wait time. And what they did once they found out that it was get state, they went back and looked at the table. And what that table was like I said, everybody logged in, and it would actually get the state of what they were when they logged in. And then it would keep that data for a day, and then there was a batch job that ran every night that would clean the previous day's data. Well, they had a maintenance window, and they stopped all jobs, and that batch job didn't get put back. So what happened was that table was growing by leaps and bounds, and it just got slower and slower and slower, as we see in that picture. So once the DBAs found that, of course, they deleted the obsolete rows, and they reduced that wait. They actually did some more work. They actually rebuilt the indexes because it was all fragmented after they deleted the rows. And then they decided because of that write log, they were going to resize the transaction logs as well. And so they got it down from 8 hours to 30 minutes after removing all that data. So, and you can kind of see that there from doing it. They kind of was working on it through the end of the week. So they got it back down even better than that Monday morning or whenever they were looking at it first. Now, this is something that seems so simple, but a lot of times when you're looking at thousands of SQL statements, without this type of view and knowing what spent so much time in the database, it's hard to find. Okay, the next case study then is on a network issue. And this deals with this access program, and I see this a lot even today with Microsoft Office as well. And basically, the screens and access were taking a lot of time. Access developers were blaming the SQL Server DBAs. Again, another finger pointing scenario. And you can kind of see here, this is kind of showing by program, and we can kind of see that Microsoft Access on those 2 days there, basically there's a job too that we should be looking at, but it was really the Access people that were complaining. You know, they're running along just fine, that blue bar, and then all of a sudden on those 2 days it just really went haywire. So we drill down into what that program was running, and we can see all the SQLs coming from Microsoft Access. And you see, none of them spent any time in the database except the one that we named Pad Image. And basically it you know, was all on network IO. That is 2000 database. But all on network, async network IO, and really what that is, you know, like I said, it could be a network issue. So we found it right away with our response time analysis. We went to look at the code, and the code here basically, if you look at it, you know, is a select image and image title, nothing much, from TBL Pad Image, you know. So, you know, what's wrong with that? Anybody? Anybody?
Nowhere clause.
Yeah, nowhere clause. I mean, you might want to blame the network, you know, administrators, because, you know, this async network IO description says often occurs, you know, when a network writes, when the task is being blocked behind the network. You know, it may be blocked waiting for client to receive data. You know, but one of the solutions is to check your network. You know, so let's go blame the network guy. But really what it was, you know, is, you know, this query had no where clause. And, you know, so what was happening is Access was sending the query to SQL Server. SQL Server was giving it every row, and then it basically did this with another table too, and then joined those tables on the client to get its results in. So effectively tying, you know, what relational databases are good at is filtering, you know, and quickly getting that data back. And so this effectively, you know, ties any way of tuning unless you actually intercept this somehow and create views so it's only returning the right thing.
There's some versions of business objects, and I don't know if it's business objects reporting or crystal reporting, but it does the same thing. If they use the GUI at the client to do stuff, it goes to this big, huge database server with all the memory in the world and brings all the data back to their little laptop, or to the business object server, which has a little memory. And then it applies the on clause for the joins and the where clause and all that selection criteria. So when you're dealing with large data and they're wondering, like, why is this taking so long? It's because they need to change how they code to maybe use a store procedure or something which will then get the data on the database server.
Yeah.
And just ship back what they need.
What they need, yeah.
So business objects has a problem.
Yeah, I forgot about that one because I've seen that too. And it effectively ties the DBA's hands in order to tune, because there's nothing you can do about it unless you reverse engineer what data they're trying to get and somehow come up with views. And believe me, in my 25 years, I've done that. I've gone back and reverse engineered. Had to, because they fired all the Access programmers and we didn't have anybody to rewrite the software, but they still needed the code. And so, and it's ugly. It's ugly to go there. Okay. But good feedback. That's great.
Yeah, this is obvious. And then I don't know if any other DBAs get this, but if you have a query with 30 joins in it, it will not be sub-second.
So figure.
So there's some people who have but I've joined it properly. It's not going to take a minute. It's going to take longer depending on the data and the where clause. So, you know, and it'll show in there, you know, the CX packet weights, things like that.
Yeah. Yeah. Okay, so the last case study I have for this is basically, you know, high CPU usage. And this is one I remember very well because it was a motorcycle shop that had a web application. And they had bikes, and then you get on to buy all this stuff for your bikes. And they called in, and they were experiencing high CPU. And they really were questioning, the management wanted to throw servers at it. Let's get a new server, get it in here. I'm tired of this revenue generating. Let's throw hardware. And so basically, they were asking me, to look at the stuff, at their actual application and see what was going on. And so here, we looked on this day, and this is back pretty old, 2007. You can see this chart, but I remember this very well because I couldn't believe this query. When you look here, you can see all what they were running. And the top, 2 or 3 SQL statements, basically we're spending 2 hours of CPU time. We were looking, in a 24-hour period, but this top one was actually spending 4.5 hours on CPU. Now, that to me looked pretty excessive. And so it was a web, we named it, or they had named it Web Load Item Styles Closeout. And then there was another one that was Web Load Item Style Byte. And so we actually looked at those. And so, quickly you can see that the response time analysis data told us where to look. Those 6.5 hours a day were spent on those top 2 SQL statements. So, I don't know how many CPUs they had at the time, but it was excessive. So when we go and figure out what CPU is, when we're looking at CPU, remember when I was talking about sys processes, you looked at that wait type, that binary, and if it's 0, it means it's not waiting on anything, it's on CPU. And so that's what CPU is. It's using CPU or waiting in a CPU queue. So it's not waiting for anything else. And when you see that, it's typically doing a lot of memory reads. And so, a lot of the fixes to reduce that time spent on CPU is actually look at, the memory scan that your queries are doing, and basically, find the ones that are reading, either doing full table, clustered index scans, or basically doing using indexes that are not efficient and not as selective. The other solution is to try, issuing fewer queries, of course, so you don't have as many things on CPU when you're running this. And then also, basically, you can check and try to move things around. If you're running batch jobs along with your OLTP systems, maybe try to schedule them at another time. But when you look at this query, and that was this, one that it's the Web Load Item Style Closeout, notice how many executions it did in that 24-hour period. It did 40,752 executions. Look at the logical reads, 5 billion. It's probably thrashing memory. When you start having that many logical reads for any one query, and you've seen all those CPU queries that they had, they were thrashing memory, so nothing was staying in memory very long. And that gives me, an idea to go look at what will we look at to see if that's happening? Page life expectancy, right? I want to see how long things are staying in memory, because they weren't probably getting a chance because there were so many logical reads for these inefficient queries, right? So to fix that, we found the CPU usage and the wait problem was to be 100% of total wait, right? So I left them with this, no go get another CPU, or don't get a new server because you're just going to use it. Because these inefficient queries are just going to take more memory and more memory and more memory. So, and run your CPU in the ground, you need to tune. And so they were going to go back and look at their index usage to reduce the amount of reading in memory. And then they're also going to look at moving off some things and try to run other things that weren't on their website to other times in the day. Now, I don't know the outcome of this. I don't know if they actually did buy a new server, but that's what I suggested that they actually tune. Okay, so that's my case studies. In summary, conventional tools, will show you system health, but they can't really help you find what your end users are waiting on. And that's where you want to, beef it up. I always say, if you can, I worked for a telecom company for years, and actually US West was, it's now CenturyLink, they got purchased, and they had 14 states out west, and we had 5,000 sales reps. And we had a B2B, an OLTP customer service, application. And I used to say, you got 5,000 sales reps. if we could speed this query up, if it's taking a minute, that's, 5,000 minutes each order that they create if you've got an order entry system, that they've wasted. If you could speed that up, you could get in more orders. And that's the way you affect the bottom line as DBAs and developers, is get the business to run efficient. The new broke, we have now a new saying, they're saying the new broke is slowness. And, it's broke when you can't get your company to run efficiently. And, that's what we do. We run systems to help the company run. Any questions? Did I put you to sleep? One thing, you can do, and we do have a free tool out there. If you want more information on weight cuts, or, I always tell people just download our tool, and you can see a lot of these weight types. And let's see if I can get to this. We actually, part of my job is basically to, when new weight types come out, is to, come up with solutions and how to reduce the time spent. We work on that each new release. But I thought I'd bookmark, let's see, weight states, maybe it's here. Oh, I don't know, can I leave this page? I don't think I want to leave this page, do I? Let me see if I can get there. Here. Sorry. Does anybody have any weight types that they want to know some information on? I mean, we do have documentation on all of them. And like I said, we do have a free product that you can download, and you can kind of get these little, what is a latch UP? And so you can kind of get that definition here of what a latch UP is if you're having that. Question?
Jan, do you have, are there weight types related to linked servers? Because we have people that try to do joins through linked servers, and we seem to always have performance problems.
And that's usually, I think that's usually an OLEDB weight. If you see that, it's going to be an OLEDB. And let me see if I can bring that up. Yeah, linked server queries. So if you see a lot of OLEDB, what I would advise is, take that query, and if you can get the SPID while it's running, take that query and run and see what it's doing on both sides. Find the equivalent and see if you can speed up the other side. Because a lot of times, if you're waiting on this side, no OLEDB, the other side's too slow. Maybe it's doing something silly like a cluster index scan over there to get it back. Because it kind of loses its brains once you have that linked server connection.
Yeah. There's a lot of problems with linked servers. The optimizer can't really, like if you have a join and you have a filter down on the bottom, that filter doesn't actually pass up. The server you're querying against will say, okay, give me everything for this table, yank it across, and then it'll filter your query. We've done temp tables to pull just what we need from the linked server and then join on and return the results. And then also open query, where you can do a dynamic query essentially.
Yeah, we just tried that.
What you need.
Well, a lot of our linked servers go to Oracle, and so we figured that might.
You're even worse off. Yeah.
So, but as soon as we replicated the data to a local table, the problems all went away.
Right.
But I could always see through the execution plan that the linked server was always my bottleneck.
Yeah, and you'd have to rewrite the query to pull less data across, and just. All right, now I need to go to a linked server and get the data, just this, now pull it back and work on it. You can't rely on SQL's optimizer to help you out at all.
Did you also try doing like a view on the source, on the link? A view which had that filtering in it, and then the view in the join to the other side?
We didn't try that.
Did you think that would help?
Rewrote it to basically use dynamic SQL to say, pull these values with this filter, and that was the solution.
Temp table.
Temp table, and then work with it from there.
Yeah. Because, you know, the optimizers on any instance, and this is all database types.
Yeah.
And anytime you try to link different instances together, they only know what they've got. They don't know what the other database has got, so they do silly things. So probably the best way. Any other questions? You know, like I said, this is a, you know, look at weight types. There are a bunch of, I was noticing there's also several other presentations out on the web if you want to, you know, Google and actually get accustomed to them. But if you start looking at them, there's a lot of resources out there to tell you how to fix the problems if you have too much time on.
We'll just take a short break, you know, stretch. The restrooms are on the other side of the elevator, make a left, and a short break, and then we'll come back to the second presentation.
Okay, great. Thank you.
And Cynthia Brown, well, actually, when we were doing the database design, we talked about that.